Hello, I'm Anna Mackay and this video is on expected value and it's part 2 of 3. So here's an example. When a die is rolled, each number has the same probability of being rolled, as you can see here by the 1 on 6 probabilities. And the different outcomes are 1 through to 6. Now for every 6 rolls, we would expect that on average each number would be rolled once. That's a fair assumption to make. But that may not actually happen. But so in the long run, over many rolls, what number do we expect to roll on average? Now it's a tricky thing to try and think about. Usually in terms of averages, we would add them all up and divide by how many numbers are there for an average. But for probability, we technically have to multiply them by the probabilities of each outcome happening. And so that's how we get our expected value. So we've got the chance of 1 happening is 1 on 6, the chance of 2 happening is 1 on 6, adding them all up, and the number that we get is 3.5. So that's a bit hard to get your head around, that on average that the number that we expect over many rolls is 3.5. So that's the mathematical expected value. Obviously you can't roll 3.5 because it's a 3 or a 4, but that's the idea. Here's the technical definition of expected value using summation notation. And so we have capital letter E and capital letter X, and that's essentially the mean, the average, and here's using the summation notation. There's a lot in this video, so we need to move on. If we have to use this to find A and B in the following discrete probability distribution, now remember this is the distribution of discrete probabilities. These are all probabilities. So we have 2 unknowns, so we need 2 equations. So let's try and create some. First of all, we know that the sum of all of these probabilities has to be equal to 1. So if we add up A and B and each of these probabilities, we can put that equal to 1. So I can write A plus B plus each of those. Obviously we can do the numbers first and then A and B, it doesn't really matter, and they will all equal 1. Simplifying that, we'd have A plus B plus 0.5 is equal to 1. Now I'm going to write this with the A and B because eventually we're going to need to solve. Now our expected value, just to tie on to what we were talking about before, is like the mean. So essentially what we're saying is if we take each of these expected outcomes and multiply them by their probability and add them all together, we'll get this expected value. So I'll just do the unknowns first. 1 times by A is A, and then here we have 3 times by B, so we're adding that on, and then we're adding on all the different other combinations. 0 times by this, well that's just going to be 0, so we don't have to worry. 2 times by 0.35. The next one, 4 times by 0.03, and the last one, 5 multiplied by 0.02 is equal to this expected value of 2.02. Simplifying that, we've got A plus 3B plus 0.92 is equal to 2.02, and therefore A and plus 3B is equal to 1.1. We now have simultaneous equations. So you would have learned about how to solve them in previous years. Your 2 techniques that are commonly used are either substitution, where you make one of these the subject of the equation, so A equals 0.5 take B, and substitute that into the second equation and solve, or use your graphics calculator. So I'm just going to quickly flick over to a graphics calculator now, and just a refresher on how to solve that. So here we are. We've got these 2 equations. For Casio, it's in the equation menu, simultaneous, 2 unknowns, and here we are. So the coefficients 1, 1, and the C value 0.5, 1, 3, 1.1, solving. So we have A is 0.2 and B is 0.3. So add that to your notes that you're taking down. Now, moving on to the next one. So we've solved that one, moving on to our next example. So I want you to pause this video so that you can read this through to save me having to read it. I'll assume you've read this through. Okay, so part A. Over a period of 30 working days, on how many days would the waitress expect to serve 6 tables? So let's have a look. Serving 6 tables has a probability of 0.07. So we need to multiply that by 30. So over 30 working days, the chance of serving 6 tables is that probability. So we have 2.1 of the days she would expect to serve 6 tables. So that's just a starter. Next, so I've just rewritten the table here. Explain why the waitress is equally likely to serve at least 8 tables as she is to serve less than 3. So writing out, the first one is we want at least 8, and the second one is less than 3. If you're somebody that gets stuck on knowing when to include the 8 or the 3, here's a tip that I do. I ask myself, at least 8, so does that include 8? So I say to myself, is 8 at least 8? Yes, in this case it is, so that's why you have the equal to. And the second one, less than 3. So ask yourself, is 3 less than 3? No, we only want 2 and 1, and so that's why we don't include the equal to on that one. All right, so let's have a look at the probabilities. At least 8, so we have to take into account these probabilities here of happening. So we'll write them out quickly. Here's the probability of 9 tables, then 10 tables, should put a plus there, then 11 tables, 12 tables, and I don't have to add on the final 0, and that is equal to 0.15. Now, probability of serving less than 3 means 2 and 1 tables. And we've got 0.05 plus 0.1, and that is equal to 0.15. Go back and read the question. Explain why the waitress is equally likely. So we've shown mathematically why, but we need to make some comment. And so we'd say equal probability, therefore, or that's equivalent to equally likely. So always make sure you go back and read the question and comment if necessary. So same question. We've asked to find the expected mean daily earning of the waitress. So first of all, we've got to work out, well, how many tables is she going to serve on average then? And so that comes by multiplying each outcome by its probability and adding them all up. So I'll just write out a couple here. We have 1 times by 0.05 plus 2 times by 0.1 plus all the way to the end 12 times by 0.01, and I'll add that up for you, 4.77. So that's the number of tables that she's expected to serve, but that isn't her earnings. So we need to use the question here, and an equation we might write is that she will earn $150 plus any tips. So she'll always earn that $150, and then we're going to add on, it's $8.50 multiplied by the expected number of tables. So if that was an equation, we might write it like that. And for the probability way of writing things, we might write 8.5 by the expected number of tables, adding on that 150. Calculating that, so e to the x, as we've calculated before, is this 4.77. So that's roughly how many tables she's going to serve on average, and I'll calculate that for you. $190.55 is her expected mean daily earning. Last part of this question is, just pause it while you read this. Okay, so her sister in America, assuming the same probability distribution applies, so she doesn't get that base 150. So if she serves the same expected number of tables, so that 4.77, and that she's going to earn the same amount per day, we have to work out how many, in tips, that how much she'll need to earn per table so that she gets the same wage. So that's the hardest part, constructing that equation. Once you've got that, you just solve for A. You'll get better with practice at doing these types of questions. So she'd need to earn that in tips per table. That's how America runs, on tips. Okay, our last example has two methods. Pause the video while you read the question. Okay, method one, we have to, or both methods, we draw up the probability distribution table. So, hope you're getting lots of practice at drawing that up. You put a little x there, and the probability, capital X, is equal to little x. So you go through the question and write out, fill in the table, so to speak. So the company estimates being called out once per month is this. So you might go 1 there, a 0.05, twice per month, 0.02, 3 times, 0.01, and then you might be thinking to yourself, I'm done. That's all that's mentioned there. This is the classic thing where people get caught up. You need to make sure that this row adds up to 1, and currently it does not. So there's a remaining probability that is left over, 0.92, and what does that go with? That's the number of times they don't get called out. So for all of those TV computers that don't break down, 92% of them, they're not being called out for those. Now, don't worry that the zero's at the end here, as opposed to at the beginning. It doesn't matter if these are consecutive or not, or even in order, as long as the probabilities add up to 1. So in this case, what is our capital letter X? It's the number of calls, because method 2 will look at it in a different way. So the number of calls, 1, 2, 3, or 0 number of calls. Now, our expected amount of calls that's going to happen, it's like the average, multiply, 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 and add them all up, and we get 0.12 is the expected number of calls. But what's the gain by the company? So the formula that we're often using for expected gain here, so I'll write here gain for month is, oops, hang on, I mean to write a G here, G for gain, is, so we start with the $50 per customer, and then we have to take away the likelihood of being called out. So take away 80 EX. So 50 take away 80 times by 0.12, and we calculate that, and we get $40.40. So the company can expect to gain $40.40 per customer each month. The other way of looking at this is if you take the gain into account while you're constructing that table. So in this case, if you have X is the gain per month, you might work that into your table to start with. And both are perfectly accepted. There's no real right or wrong here, provided that you set it out correctly and sort of explain what you're doing. So again, read through the information. So if they get called out once, a customer's paid $50, but it costs the company $80. So we've got that 50 less the 80. So if they get called out once, they're actually losing $30. So that's another way of writing it. The chances of that happening are that one call out. What's the next thing that could happen? Ignore my terribly straight lines here. If it's 2 lots of $80, 160 there, they've paid the $50, but the company's now lost 160. So the total gain or loss in that sense is 110. So I'm working that into the table to start with, and that's 2 call outs, and the 3 call outs would be $190 loss. But then remember, there's all of those times that they don't get called out, so they are making that $50, and there's the probability of that happening. So our final expected gain for that is where you multiply, 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 add them all up, and that's how we still get back to our $40.40. So two ways of looking at that. Okay, so that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel. And the next video is still expected value, but it's the third part in the series. Thank you.